All is well, Mr. Shand. Mr. Shand.
All right. Are you hearing me now, students? I don't understand what is happening.
Yes.
Oh, okay. I was trying to have a conversation, but clearly I was speaking to myself. How are we? All right, there are only six of us here. Hi, Dana. No, he decided to connect. Oh, Chetty said she's not hearing me. Oh, Lord. Um, Dana, are you hearing me? I guess not. Donald is hearing. Atara, are you hearing me?
Yes, sir, I'm hearing you.
Okay. Jojo, are you hearing? Uh, it's not working at all. Daniel, are you hearing me? Oh Lord, help me. It's probably just me. All right.
I hear you.
Yeah, but I'm hearing. Donald is hearing me, and Atara is hearing me.
Them gone to the bathroom. Them there in the kitchen, I'm outside.
That me a thing to hear, Papa. That me a thing too. All right. Mm, all right. Dana, are you back now? Chetty, you hear me now? Oh Lord. Now see if there's internet issues. Today is audio issues. Okay. Donald, Atara, can you speak for me, please, and ask your classmates if they are hearing you? Let me see if I'm the problem.
Hi everyone, are you hearing me?
Well, I hear you. I heard you just know Atara. Donald, did you hear Atara a while ago?
I did. Check the chat.
Hearing.
Are you hearing no
So
Joe?
we're hearing you, sir.
I
We're
was
hearing you.
always hearing you.
Oh, so I want to talk to myself, so sure. I just felt like I was having a conversation by myself. That was not a nice feeling. All right. Where were we the last time? By the way, how you do? You good?
Sir, we're just there.
You just- Aye,
Yeah,
aye, aye.
just there, sir.
Mhm. Not no better than John Shapiro. Not a thing no better than where John Shap have to sell. We are just existing. Where were we the last time? The last time I looked at, and I'm trying to remember. This is calculus 2. No, this is calculus 1. This is calculus 1. All right. We did piecewise function the last time around. We did piecewise the last time around. What was the last thing? Oh, right. So the last time around, which was last Saturday, we should have completed. Did you complete the those questions that were placed in the group?
So I think I was stuck at one of them.
Which one were you stuck at?
So I'm gonna look, because I did send it in the group. Sir, the one over with the AX over 2 minus B.
X over 2 minus B. All right, I kind of figured. All right, so, all right, give me half a second. Let me just start writing, please.
Sir, same for me too, sir. I did it, but I'm not sure if it's correct, so.
There are no apples today. Oh Lord. My writing implement. Oh, there you go. So you were hiding right there. And I'm now looking for. Okay, there you go. There's a pen. There you go. Yes, I. And when you see the solution to the question, you're going to say, geez and peas, but I could do it. It really isn't difficult. It looks different, but pretty. They're pretty. Mm. Hold on a minute, please. Hold on a minute. Where's this thing? Oh, she's so fuzzy. I am the one. All right, so the foolishness has started again. And I'm not into it. Let's try this one more time.
Board is not open. You're not showing any board right now. Oh no, it's showing.
Guys, I'm here talking to myself. Remember, when I start sharing screen, it takes me to a view that automatically mutes me.
Is that so?
Yeah, man. So I'm here talking to myself and ask a question and not getting a response. So let me go again. I'm checking to see if it is continuous at x equals 2 and x equals 5. Which other function? I'm going to look at x equal 2. Which other function deals with to the left of x equal 2? Hmm?
Sir, the first function.
Very good. The first function. So let us look at to the left of x equals 2. Anywhere in the function I see x, I'm substituting 2. I get x. I get a function to 10 to 1. Do you agree with that? Hmm?
Let's see here. Works out.
Correct, sir.
Hmm?
Yes, sir. Correct.
Okay. Which function leads to the right again? Which function leads to the right of 2?
Second one, sir.
Good. Good job. Second one. Anywhere in the function I see x, I'm putting 2. So I'm going to have 2a over 2 minus b. But are we to make the function, is the function continuous at x equals 2?
Sir, yes.
Mm-hmm. Hold on.
Sir, stop sharing just now, right?
Clearly, this thing wants to play. And I will not have it. Are you with me now? Again?
Yes, sir.
All right, so it is telling us that it is continuous. It is telling us that it is continuous. So what all of this is supposed to be equal to?
Sir, 1.
1. Very good. Why 1, sir? Because if it is continuous, both left and right must yield the same answer. If it is continuous, both left and right must yield the same answer. If they don't yield the same answer, that means it's not continuous. So you're going to set it equals to 1. Oh, sir, so whenever we get a question like this where we have the unknown, it's best for us to work out the left-hand side first. Yes. Yes, it is best for us to work out the left-hand side first. Sorry, you're eating sweetie. Let's go.
Sir.
That cancels this. So what I'm going to let it know is going to be a minus b is equals to 1. Call that my equation 1.
Sir.
Mm-hmm.
Before you reach down there, you can go over the top part, please.
Which one?
The same one you're on now.
Over here?
Yeah.
Mm-hmm. Ax. Which function deals with the limit going to the right? See here, x is going to the right. X is greater than or equals to 2. That's going to the right. So since it's going to the right, it means this is the function that I have to use. Ax over 2 minus b. So I have to use this function. All right? Now, anywhere in the function, I see x, I'm going to substitute 2. Anywhere in the function, I see x, I'm going to substitute 2. So x beside the a here. So it's a times 2. A times 2 is 2a. Tell me that you agree with me.
Agree, sir.
Over 2. And the 2's cancel. I'm left with only a. Agree with that?
Yes, sir.
So I'm going to have a minus b is equals to 1. So that's going to be my equation. Now I can't solve an equation with one unknown. So what I need to have now is another equation. I have to get another equation so that I'm able to solve them simultaneously. Whenever you get a question like this, it's going to be end up with a simultaneous solution. Trust me. Every time, always. All right? Tell me that you agree.
Agree, sir.
All right, let's go. So we need to look at the limit. As x tends to the, where's the question? Hold on. I'm going to look at the right of 5 first. So why? Because the left of 5 has an unknown, so I have to work the right of 5 first. When I work the right of 5 and I get that unknown, I'm going to set it equals to the left of 5. Do you agree with me?
Yes, sir.
What function leads to the right of 5?
The third one.
Very good. Minus 7 plus 2x. And anywhere in the function I see x, I put 5 minus 7 plus 2 times 5. minus 7 plus 10. And that is equals to 3. So what is going to be required of me now is to now investigate the limit as x tends to the left of 5. The limit as x tends to the left of 5. Now the left of 5 is which of the functions?
The second one.
Very good. I'm happy that you guys are able to figure it out. Ax over 2 minus b. Now, is it just like how this one was supposed to be equals to 1? This one's supposed to be equals to how much?
3.
Excellent. So anywhere in the function I see x, I'm going to substitute what number?
3. Oh,
Mhm.
5, sorry.
5. So this is going to be 5a over 2 minus b is equal to 3. And this is my equation 2. So I've completed the first part of the question. I don't get the value of a and b yet, I just complete the first part of the question. Let me know if you are okay with what I have.
Yes, sir.
Yes, sir. I'm okay.
All right, good. Done.
Yeah, I'm all right.
Donald, where you stay?
I am here.
All right, good job. Ax minus b equal 1. Five a over 2 minus b equals 3.
Screen for a sec. Oh, go back to the other screen for a second, please.
I come in.
All good.
How do I go about doing this?
So it's all for B.
Yeah, but I'll do something first with the equation 2.
You won't do that yet.
Times equation 1 by 3 and times equation 2 by 1. Well, never mind. That
I'll
doesn't work.
just
Subtract.
okay. Yeah, all right. You tell me what you need to do because it can be done either way. So you want me to subtract one equation from the next?
Yes.
Okay. Which one from
Sir,
which?
shouldn't that be 2a? Sir, a minus b, sir.
Yeah.
Not a.
Yeah. What do you want me to do?
Sir,
Subtract
subtract.
it from me.
Sir, subtract equation 2 from equation 1. Or that can't work.
Okay, cool. So say
Sir, before you do that, how do you determine
which equation to subtract?
yeah, what is when you reach this point, right? How do you determine if you're going to multiply, subtract what? Like, what is the aim at this point?
Basically, which identity is which? Like
Break it down for her for me, please.
Like we see that A is multiply is whereas that we see that A is multiplies by itself, but B is a constant by itself. Question is which is A and what is A and why is B sticking out there? We have equation 2 already. That's 54 upon 2 minus B equal 3. So that's 36 minus B equal 3.
I don't think she reached that far yet.
Oh.
What she wants to know is how do you know which equation to subtract to to subtract from the other equation. So what I would normally say is, I will normally look for the bigger of the two equations. You don't have to. You really don't have to. But I will normally look for the bigger of the two equations. And when I do that, what I do is to take away the smaller one from the bigger one.
So that you don't have to worry about a bag of negative number or whatnot.
Absolutely. That is a response, Atara, that I want. So I look for the big one. And sir, how you can find the big one? No, I have 2a. I have 5a over 2. The 5a over 2 are 2.5a. Talk truth.
Yes, sir.
So which equation bigger?
Sir,
Sir,
first of all,
second
before you do that, sir.
So we have 2A there.
Yeah,
Sir,
because
that is not
sir,
the equation.
All right, two people talking. I
Sir,
don't know who is
A
who.
minus B, not 2A.
Not 2A.
Oh,
The first equation, sir.
well, guess what? No. Even
Sir, I know
clearer.
said the same thing, mom.
Even clearer. Which is bigger?
Sir, 5A over 2.
So I subtract the smaller from the bigger. So that's what we do at Tara. And the reason, do we have to do it like that? No. But the reason sir teach you like that is because you don't want a bag of negative numbers. But sir, is negative numbers a part of the game? Absolutely. So if I get a negative number, sir, I can't use it. Absolutely. Absolutely. But I that's just how I normally do it. Because I know how you guys don't like negative numbers. I normally say, you know what? Let us do it this way. I know I'm gonna be in problems, you know. Am I in problems yet? No. Let me not do this. Let me go here. Are you clear, Atara?
Yes, sir.
All right, nice. All right. Okay, let's get this now. Two minus one. Before you move on, sir, are you saying if I did 1 minus 2, I won't get the same answer? Yes, you would. Yes, you would. You would. So it's going to be 5a over 2 minus a. 5a over 2 is how much a? 2.5a, don't?
Yes, sir.
2.5a minus a is how much? What is left?
Sir, 1.5.
Sir, what did you say a while ago? Sad word?
So 1.5. So 1.5a equal 2.
Very good. LCM is 2. 2 into 2 goes 1. 1 times 5a is 5a. 1 into 2 goes 2 times. 2 times negative a is negative 2a. 5a minus 2a is going to be 3a over 2.
You can even look at this and just say 3a, just cancel the 2 of them.
Right, yeah,
like 3a. Now upon the left-hand side,
on the left-hand side, yeah.
They have 3a, so you have 3a equal 2. You just multiply both of those by 2 to get rid of the denominator. So 3a equal 4, a equal 4 over 3. Do I have that right?
All right. So now, and then now, minus b minus b minus b equals what?
Minus b plus b equals 0.
Very good, because it's got minus b plus b, which is equal to 0. Can you agree with that?
Yes, sir.
So come eliminate the b's. That's how we would have eliminated the b's. And then now, 3 minus 1 is equal to 2. So A, B, and C side work gives us that as a response. All right? Any questions? Talk to me now.
Pretty much.
Sir, what does the side work let us see concerns? What are you solving there?
This part. Remember, it's equation 2 minus equation 1.
Oh, I see. So you're figuring out how you get equation 3. All right.
Ready? So look at this now. So I'm going to have, so what I'm going to do, I am now going to multiply throughout by 2. Why, sir? That 2 cancels this 2. So now what I'm left with is 3a is equals to 4. 3a equals 4. Got me? Hello?
Repeat, sir.
Now I'm saying I'm now going to end up with 3a equals 4. Do you agree?
Right.
Because you got rid of the 2, so on one side you do the same side. So that's how you get a 4, right?
And then a now is going to work out to be 4/3. The value of a works out to be 4/3.
So, you know, so many that bust my brain that day and like never realized it.
It's not hard, man. It's not hard. Trust me. Talk to me.
What next today?
All right. So what I'm going to do now is to put A equals 4/3 into one of the equations, say A minus B equals 1. Why, sir? It just looks easier to work with. So anywhere in the equation I see A, I'm going to put 4/3. So this number becomes 4/3 minus B is equals to 1. So what I'm going to do is to say 4/3 minus 1 is equals to B. And that is over 1. LCM here is 3. 3 into 3 goes 1 time. 1 times 4 is 4. 1 into 3 goes 3 times, and 3 times -1 is -3. And 4 minus 3 is going to be 1. So B is equals to 1/3. So B is equals to 1/3. Talk to me.
Pretty much.
Taro, where you stay?
So you can go over that part again for me?
What part? The substitution part here?
Yes, sir.
All right, so because I find the value of A, I calculated the value of A, I now need to find the corresponding value of B. I now need to find the corresponding value of B. I need to find the corresponding value of B. So in any of the equations, I can select to use. And what I've done is to say, you know what? Let me substitute into equation 1. So why never use equation 2? Equation 2 have 5A over 2, and it just look like more work for me. So I'm just going to use the simple of the two equations, which is A minus B. But I guarantee if I use the second equation, I would have gotten the same answer. I'd have gotten the same answer. So what I'm doing is substituting into equation 1. Anywhere in equation 1 I see A, I'm going to put 4/3. See A here, so I put it at 4/3. So it's 4/3 minus B is equals to 1. And then now I'm adding B's to both sides because I want to get rid of it from here. So now add B to both sides. This one cancels, and I'm going to have a B on this side, which is here. And I'm subtracting 1 from both sides. So this one will remove from here, and I'll get it over here. So I'm going to have a -1 here. So I'm going to end up with 4/3 minus 1 is equals to B. All I need to do is to evaluate this fraction, or these fractions. 4/3 minus 1. LCM is 3. 3 into 3 goes 1 time, and 1 times this 4 gives me this 4. 1 into 3 goes 3 times, and 3 times -1 is -3. And 4 minus 3 is equals to 1. Over 3. So my A is 1/3. My A is 4/3. And my B is 1/3. What was the question? What the question asked us to do? Find the value of A and B. 8 marks. Let me know how you stay.
Okay, so fine.
Waiting for you to tell me how you feel. What's your stress level?
Just need some coffee. I'm good.
Man, Starbucks is just around the road. You can get a latte. All right. Dan, not hearing from you.
I understand.
All right, good.
If I could afford Starbucks, I would be going back to school.
Yeah.
I'm paying a cup of nothing, man.
When you can do it yourself, don't.
Yeah, man.
Trust me. You can do your own blending, sir. All right. How we feel with that one?
Sir,
Yes, please.
before you move on, I think I got myself lost at B. Interesting. I get below it, but B just kind of have me lost.
This one here?
That's correct.
So this is what I was working out. Remember we said it's going to be equation 2 minus 1. So this one is equation 2. So it's going to be minus B minus B. And these two negative signs here negate each other and become a positive. See it right here, so now have negative B plus a B. So adding similar numbers with different signs gives me 0.
Okay. Oh, I get it now, sir.
Yeah, man. How is the talk to me now? How is the
Next topic.
all right? But before I do that though, say
How far the business calculus class reach?
so them we not compare ourselves with them. Them doing them we not compare ourselves. Our program is a little bit more it's a little heavier than what they do for business class. Dan, are you okay? Chetty, or you stay? Well, yeah, Chetty, or you stay?
Sir, I'm a good man.
You sure?
Yeah.
Dana, Dana.
Yes, sir.
Me not understand how you like you want to keep money to the teacher. You know, say teacher will send Joanna and Donna for you. Or you stay, mommy?
Sir, I'm good.
All right,
Sir, you
nice.
hear me?
I'm hearing you now, Hona. See that you dropped off and then you're back now.
Sir, I'm not seeing the screen if you're sharing.
I am sharing. You are supposed to be seeing.
Oh, sir, I've seen it now.
Okay. All right. You sound like you're not ready. All right. All right. What should I do? Were those all? Alrighty then. I want us now to move into some I want us to move into some other stuff. Before I move into those areas, we need to move into our basic oh, thanks, Donald. I'm trying to find it. Oh, no, that's not where I look for it. Search and I look for it. This is applications to integration. No, that sounds like calculus 2. I'm trying to find their stuff. Application to differentiation, that's calculus 2. All right, I'm not seeing my document. I'm using a new system and it gives me some limitations, one of which is the muting of the stuff when we go. Oh lordy.
Sir, question.
Yes, please.
So I'm looking at the draft exam timetable, and I'm not seeing a date slated for calculus.
Calculus 1? You're not seeing calculus 1 at all on it?
No, I said pre-calculus,
Okay,
business
thanks for that
calculus, and
information.
calculus 2.
Thanks for that information. I need to let exams know. Thanks for giving me that thumbs up. I need to speak with
Sorry, I
exams.
thought you knew.
I didn't. Was I the one who sent it out to you?
Yes, sir.
Yeah,
So you sent it in the calculus group.
Right. I never normally check those things. I let the students do it, and I never normally tell students when they have their exams. I let students say it, and if there's a difficulty, then they will communicate the difficulties to me. But thanks for that information. I will definitely pass it on, because I don't, I've had a student who said, "Sir, but you told me that the exam." I said, "Me? Yes, sir. So I stay far from it. As close as we are, I'll rather send you a copy of the timetable for you to look for it. Even if I know, I'll send you a copy of the timetable for you to find out for yourself. Not doing it. Saving myself, preserving myself.
Didn't get that one. Where would I find it?
It's all right. I can. Joe, can you forward it to this group for me, please?
Okay, sir.
Thank you. I'd send it in the calculus 2 group. Forgive me for not sending it over here. So I just get asked Joe to just forward it. Yes, please, sir.
Donald should find it at the website.
Yes, also on the website.
Yeah.
I give thanks.
It's also on the website. All right. Let us look at what we'll call it now. It's hold on. It's at the back. Give me a few, guys. All right. What I'm going to be doing with you just now is I'm going to be looking at some more limits of a function, but this time we are going to be using it to introduce our differentiation. We're going to be looking at limits of a function, but we are going to be using it to speak about our introduction to differentiation. Um, our first principles differentiation, and this is what is going to happen. Say I say to you, evaluate the limit as h tends to 0 of 2x. Now, what it is that we're going to be doing, by the way, are you hearing me?
Yes, sir.
I hear you.
Okay. All right, good, good. Now, you notice what we're saying? We are differentiating the limit as h tends to 0 of 2x. It means that they're asking us to differentiate that function, but we're differentiating it using first principles. We're differentiating it using first principles. Now look at this formulation. F of x plus h minus f of x all over h, the limit as h tends to 0. That's my formulation. My formulation is going to be f of x plus h minus f of x all over h. Now hear the story. You know, sometimes you cook rice, you cook a good chicken foot soup. Nice, yummy looking, yellow, creamy, nice chicken foot soup. And inside of this chicken foot soup, you're going to put your scallion, your thyme, your pimento, your garlic. Some people put cloves in it, and the likes. When it is that you're drinking your soup, do you want to see the scallion, the thyme, the garlic, and all of them something there in the plate? Yes or no?
No, sir.
No, I wouldn't either. I wouldn't. So what I personally would want to do is to take it out, is to take them out. And in taking them out, that's exactly what we're doing with our differentiation. First principles. I'm going to put in something into the function, this increment called h. I'm putting this increment called h is what I'm adding to my f of x. My f of x is going to be added to h, a small increment. Now, this small increment is going to remain, but I'm going to take over my f of h. So all what I'm saying to you is, this is your chicken foot soup with all of the seasoning them inside of it. But you're going to share out the chicken foot soup and leave the seasoning on the pot because you don't want the seasoning. The seasoning already did what it is supposed to do. True or false? Somebody talk to me now, please.
Which is right.
All right. So look at what is going to happen. And incidentally, let me just say this as a disclaimer. I get my energy from from when I'm
Feedback.
teaching and I get the participation. Yes, the feedback is what gives me great energy. When I don't get it, I feel lethargic. I feel lethargic when I don't get it. So please, just work with me. All right, let's go. So look at how we're going to do the question now. Every time I end up calling a x, I'm going to add a small increment to it, a plus h. So look at me. Look at me. It's going to be the limit as h tends to 0 of 2x plus h. I'm adding my increment, 2x plus h. And that is going to be minus my f of x. What is my f of x? My f of x is this 2x all over h. Every time I call a x, I'm going to have x plus h. Every time I call a x, I'm going to have an x plus h. So it's going to be my 2x or x plus h minus my function now, minus my original function, which is my f of x. My original function f of x is this, 2x. So I'm subtracting it all over h. Sorry, I have to put over h? Yeah, because my limit tends to h. Look at what happens. The limit as h tends to 0 of 2x plus 2h minus 2x all over h. Oh, sir, but something can happen right here, sir. I'm seeing where this 2x cancels with this 2x, and you are correct. Those 2x's cancel. So what I'm going to be left with is going to be the limit as h tends to 0 of 2h over h. Sir, I see something else. I said, what have you seen? The h is also cancelled. Very good. So all I'm going to be left with now is the limit h tends to 0 of 2. Hold on. But I can't find the limit of 2. What's the limit of 2?
0.
No.
A constant, yeah.
What's the limit of 2?
Oh my bad.
What's the limit of 2? The limit as h tends to 0 of 2 is? We always say it. We always do it. We always say it and we always do it. What is it?
As n tends towards 2, x becomes it. All right, repeat the question.
The question is, how do I find the limit of a constant?
The limit of a constant is the constant itself.
Constant itself, sir.
The limit of a constant is the constant itself. Always remember that. The limit of a constant is the constant itself. It not change. The limit of a constant is a constant itself. So the limit of 2 is going to be 2. And when I differentiate 2x, what it is saying to me? When I differentiate 2x, I'm going to get 2 for my answer. So I have just differentiated using, hold on please. Sorry. So what I've just done was to differentiate what I've just done is to differentiate the function 2x from first principles. What I've just done is to differentiate 2x from first principles. What I'm going to ask you to do for me, if there are no questions. Do you have any questions? Do you have any questions?
Not yet, sir.
All right. So what I want you to do, I want you to try for me. Just remember, oh, this is so evil. What I want you to try for me is the limit of a constant is the constant itself. The limit of a constant is the constant itself. Also remember, when you're doing your differentiation from first principles, it is going to be f of x plus h minus f of x all over h. F of x plus h minus f of x all over h. You can't not remember this formula. This formula is very important. Hold on. All right. So what happens is your f of x plus h minus f of x over h is very important. You put it in, you have to take it out. Whenever you are cooking, and I always use that as an example, whenever you are cooking and you put a seasoning in the pot, you always, every single time, remove the seasoning. Nobody eats a seasoning. Well, I don't. Unless you're doing like ackee and sawfish and you have the tomato and so forth and so. But we're not talking about that kind of eating the seasoning. But of course, you're not going to eat thyme, and especially the stalk of the thyme, right? So what we do is to take it out. We are going to take out what it is that we're not using, and then we go ahead and put in the keep the age that we have, and the age that we have here is that small increment. What I want you to do, I'm going to leave this example up front here. Clearly this was an easy question because I had only 2x. I'm just compounding it a little bit by putting 4x plus 1, just a little bit more than what it is that you would have had. I'm going to leave this here, give you about 2-3 minutes to go and work the limit of this thing, because the quicker you do this is the quicker you can move into the different rules of differentiation that I really want to start with today. So see how best you can do this for me, because the other topics that are going to be left, I will now have to use differentiation. So I have to now teach you differentiation because the other topics, you must be able to differentiate in order to use those. So I'm going to give you about 3 minutes to go ahead and do this one for me, and then I'm going to complicate it a little bit more just to see how best you can evaluate your stuff. All right?
Sir?
Start for me. Yes, hon.
Sir, can I ask you a question like on WhatsApp, please?
You can ask me a question like who?
On WhatsApp, like in
Oh, yeah,
the
yeah,
chat.
yeah, man. Sure. Send me
I'm
what's
going to
WhatsApp.
text you, sir.
No problem, hon.
All is well with Mr. Shand.
Are we okay, guys? Are we finished?
Okay, I'm finished.
All right, can I give the others 2 more minutes, please? Can you hurry for me, guys, please? All right, so Jojo says she finished. What about the rest of you? Not finished yet?
Yes, sir.
Oh, you want to tell me, say, you must tell me. Hey, Dana. I will set Donald and Jojo and it's like, want to talk to me, not the no, man, you must talk to teacher, man. All right, so Joanna, Dana, who has finished? All right, Dana, what do you have for your answer?
Sir, I got 5.
You got 5? Jojo, what you got for your answer?
Sir, 4.
Okay. Dana, how did you get 5?
So you're going to write it?
Say it again, huh?
So you're going to write it?
I'm going to write it, but I'm just asking you, tell me how you got your 5.
So I have 4, and then in bracket x plus h,
Very
close
good.
bracket minus 4x plus 1 over h.
Aha. You see that 4x plus 1? Please put it in some parentheses so we know.
All right.
Because it's not, you see that minus sign there is not just for the 4x. It is also married to the 1.
Mm-hmm.
You see what I'm saying?
Yes, sir.
Yeah, man. All right, continue. I'm working it in my head, so continue. Talk to me.
Okay, sir. 4x plus 4h minus 4x minus 1 over h.
Very good. And then when you
4,
distribute the good,
sorry, I
continue.
cancel the 4x minus 4.
All right, and then you're left with what?
4h minus 1 over h.
Okay.
And then you cancel the h. So you're left with 4 minus 1 equal 3.
4 minus 1. I don't get. No man, something wrong right there. So you'd have had 4 times. Sorry, you're going to have 4x minus 1, 4x plus 1, 4 times x plus h plus 1 minus, in brackets, you're going to have 4x plus 1. So
Sir, I think she forgot the plus 1 in hers.
Absolutely.
Yes, sir.
You forgot the plus 1. I soon write it, but I just want to say something here. You forgot the plus 1 because it's going to be, let me see if I can write. For x plus 1, the limit as h tends to 0 of 4x plus 1. All right. So you're going to end up with no. Remember, the formula is going to be the limit as h tends to 0 of f of x plus h minus f of x all over h. Formula every time. So you're going to have, and every time you must write the limit as h tends to 0 here. So h tends to 0 of 4 times x plus h plus 1 minus 4x plus 1. Remember, you are taking out everything as a whole. So what we have now is a limit as h tends to 0 of 4x plus 4h plus 1 minus 4x minus 1 all over h. So look at what happens now. This 4x cancels with this 4x, and so does the 1. Remember, I said to you, that everything, you remember you have your pot of soup with your scallion, thyme, pimento, cloves, garlic. When you go good restaurant, you're not supposed to see no pimento, clove, thyme, garlic, scallion in your plate, because aesthetically it's not good when it's served. So, but you put it in there because it serves a purpose to season your pot. But you're going to be taking it back out. So that's exactly what I'm doing. When I do this, I must take back everything of f of x. So you see everything on this side here, watch me. You see everything on this side here, so the minus f of x right here, so all of this must be taken out. So I can't just cancel out the 4x alone and leave the 1. The 1 has to come out also because everything must be taken out. So what I'm going to have now is the limit as h tends to 0 of 4h, talk truth, over h. And then the h is cancelled. So I'm going to end up with the limit as h tends to 0 of 4. What is the limit as h tends to 0 of 4 equals to?
4.
4, because
The limit of a constant is a constant itself.
the limit of a constant is a constant itself. Teacher is not upset because teacher gives you the work, and it is for you to do the work to see how best you're understanding the work so that you can learn from it. So I appreciate, Dana, you explaining the stuff. But my question to you now, Dana, is can you understand what it is that Atara was saying and that what it is that I'm saying with that 1 and this 1 here that they have to cancel out?
Yes, sir.
Nice job. Good job. Good attempt. Tara, you got that answer?
Yes, sir. I got 4, so that's what I got.
Good job. Good job. Good job. Chedi, is Chedi still with us? Chedi Ann, how you stay?
Yes, sir, I got it.
Very nice. Very nice. All right. I'm gonna increase the difficulty level of it now. I mean, you guys are very quick learners. You calculus 1 students would have seen it already, and the math and finance students are pretty quick. So I should have a difficulty moving on into our regular differentiation today. What am I saying? We're not going to spend the whole day on first principles. We're going to move into something else. Watch me. So this classwork now is to find the limit as h tends to 0 of 2x squared plus 7x minus 5. 2x squared plus 7x minus 5. Dan,
Yes, sir.
or you stay?
What you mean, sir?
You understand it, son?
Yeah, I'm understanding.
All right, cool. Are we finished? Are we okay?
Sir, I'm finished.
Thank you, Joe. Anybody else finish? Dana, Dan, Chetty,
No, sir.
Tara.
Not
All right.
finished.
No? All right, finish, Dan. Um,
No,
oh,
sir.
Donna. Oh, you don't finish. Oh, you don't finish. All right. Quick.
Sir, I sent you a message on WhatsApp.
Okay, oh no, all right. All right, big safe, yeah? Ready or not? Here I come.
I'm here.
Very good. So in this case, 2x squared plus 7x minus 5. 2x squared plus 7x minus 5. Remember, the formula is the limit as h tends to 0 of f of x plus h minus f of x all over h. You cannot not remember that. And then I'm going to say now the limit as h tends to 0 of 2 times x plus h all squared plus 7 times x plus h minus f of x, which is 2x squared plus 7x minus 5 all over h. Question. Who wants to share the answer with us? What's your answer, Joe?
There 4x plus 7. So you hear me?
Same.
All right, very good. 4x plus 7. All right, good job. 4x plus 7. Okay. So let's continue working. So I'm going to have now h, the limit, h tends to 0 of 2 times x squared plus 2xh plus h squared plus 7 times x plus h minus 5 minus 2x squared plus 7x minus 5. Note x plus h squared is same as x plus h plus h. X plus h all squared is the same thing as x plus h times x plus h. So therefore, x times hx, h times h is hx, h times h is h squared equals to x squared plus 2hx plus h squared. And that's what I have right there. So now I'm removing my parentheses. So I'm going to have the limit as h tends to 0 of 2x squared plus 4xh plus 2h squared plus 7x plus 7h minus 5 minus 2x squared minus 7x plus 5 all over h. Watch me. All of my f of x, everything over the side, I must cancel out with something. So now look at them. If all of them not cancel out something wrong, minus 7x, sit here plus 7x plus 5 minus 5. And no, and everything now in the numerator must have a h in it. If it don't have a h in it, something is wrong. So I'm going to say the limit as h tends to 0 of 4xh plus 2h squared plus 7h all over h. all over h is the limit as h tends to 0 of h times 4h
Sir?
for h. That h cancels with that h. So what I'm left
Sorry, you're kind of breaking up. I'm not sure it's from
with
you.
is the limit as h tends to 0 of 4x plus 2h plus 7. No, as h tends to 0, I'm the 0. So what I have is the limit. 4x plus 7 is considered a constant. So my answer 4x. Go ahead. Go ahead. Am I breaking up, guys? Am I breaking up, guys? Are you hearing me?
You were breaking up, sir. We're hearing you now.
Are you hearing me?
We hear you. It's just a bad connection.
Hold on. Let me try and fix it. Is it any better now?
Somewhat.
All right.
But it's not a problem. We can continue.
I can continue. All right. So are there any questions regarding what it is that we've just done? Do you have any questions, guys?
Me, sir.
Okay. The rest of you, who is still?
Sir, I have a question.
Go ahead, honey.
Is there a case that will get these with fractions?
They can. You want to try one?
Sir, I don't feel too confident in that, right?
Oh man, that's why we're in class, so you can try it and see how it works out. You can try. Let me create a fraction one and give to you. I need to see how that one works out. I'm thinking. 1 over x. Yeah, man, try that one. And let us see how best we can get that one. 1 over x. Try that for me. Thanks, Joe.
Sir, not gonna lie, but I don't know where to start with this one.
Follow the same procedure. Everything that we've done so far is the same thing. It's just that the function is different. Anyway, you see the x, you're going to put x plus h. Same thing. If
Hold
you
on,
want to
let's
write
try
it first,
what you said, 1 upon x, right?
mm-hmm.
Can't that just be converted to index figure x to the minus 1? You work with it from there.
Except that you can, but except that it is going to be a little bit more challenging for you to do the first principles from it like that. So it's easier to just keep it in this form. I will come back to you in a few minutes with that index form to the negative first power.
Okay.
All right. But just try and see how basic is the same thing that we've been doing. The same thing. It's just that you have 1 over x as a fractional form. So let me see how far you can go. How we stay? All right so far? It's not for me to come in just yet, you know. I want you to try it. Don't sit down and say you're going to wait until sir do it. I want you to try. All right.
Sure.
2 more.
Look.
No, start again. Look back at where it is that you've gone and start again. Give me a minute, please. Always stay. All your side stay.
Sir, still stuck.
Dan.
Oh, I'm good.
Okay, nice, Donald. Daniel, how you stay?
Yes,
Sir,
sir,
I wonder,
please.
sir, I wonder if I do something. Yeah. So, but the way I worked was in my head before on paper, it was sorry.
Yeah, so the answer that you have in your head supposed to, when you work out on paper, supposed to coincide. Tara, how we stay?
So I'm stuck. I'm stuck.
The limit as h tends to 0 of 1 over x plus h minus 1 over x all over h. Record f of x plus h minus f of x all over h. Why am I writing my h like a L? The limit as h tends to 0 of f of x plus h minus f of x all over h all over h. All right? So it is f of x plus h. Anytime I see the function x, I'm going to add an h. Then I'm going to subtract the whole function. Then I'm going to divide it by h. All right, so let's go. I need to work with my numerator first. So it's going to be the limit as h tends to 0. My numerator is 1 over x plus h minus 1 over x. LCM is x times x plus h. Then how many times can x plus h go into x plus h times x? How many times?
Sir, 1, sir, 0,
How many times can x plus h go into x times x plus h?
sir, no,
How many times?
sir, 1,
How many times?
sir,
Hint,
x
hint.
time,
Thank you. X times. What is x times this one?
sir, x,
How many times can x go into x times x plus h?
X plus H.
Once,
x
or
plus
x
h,
plus h times.
And x plus h times negative 1 is negative x plus h. And that's the limit as h tends to 0, and that is being multiplied by 1 over h. Multiplying by 1 over h is the same thing as dividing by h, I'm sorry. Multiplying by 1 over h is the same thing as dividing by h. Same difference. But I do it this one because it is a little bit more presentable. All right? But you still have to keep your h. Can't leave it out. You still have to keep your h because it has to be cancelled. All right, let us work out our numerator now. The limit
Yep.
as h tends to 0 of x minus x, x minus x minus h, all over x times x plus h times 1 over h. You will recognize that the x is cancelled. True or false?
That's true.
Good. Now watch me and watch me carefully. I cancel those, then I'm going to be left with the limit as h tends to 0 of negative h over xh times x plus h. Talk truth.
I did mine a bit differently, but that's right, yeah.
So
The rest of your
So where you get that minus h from? Negative h.
sit here.
What is not up the top? Where it is that?
Minus times x is minus x, minus times h is minus h.
Okay.
Agreed?
Continue.
That's it.
This h cancels with this h. And then I'm left with the limit as h tends to 0
Mute phone.
of negative 1 all over now x times x plus h. As x, since it's once I cancel up this, is once I cancel my h in the denominator, I can then apply the limit. I can then apply the limit. Look at what I'm going to do now. I'm going to say to you, as h tends to 0, look at what happens. Negative 1 over x times x plus h when it tends to negative 1 over x times x. So I'm going to have the limit as x tends, not x, but h. I'm not in x. The limit as h tends to 0 of negative 1 over x times x is x squared. It's going to be negative 1 over x squared. Did anybody get negative 1 over x squared?
Yes, sir.
Very good. Now, Joe, I'm going to come back to this, because Donald said that he got the answer, but he never did it this way. And I'm very curious to find out which way Donald did it. So I soon come back to that one. Joe, where are you now?
Sir, why you never just like where the negative h over xh for that part? Yes, sir. So why you never just cancel out the one above it instead of just doing the xh? Sure, that could work.
Cancel which one, Joe?
Sir, above it, the one above it.
Mm-hmm.
If you could cancel it out and you still get a negative one.
It's the same line, Joe. It's the same line, Joe. All I'm doing is that I don't want to do 2 steps in one line and say that I jump in the gun. So what I did
Okay,
was to just, yeah.
Oh no, for this one, I just multiplied out everything. I made it longer than it needed to be. It's like where you would see x minus x plus h in brackets. That was actually multiplied out. Should have went ahead. Yeah, nah, just mine is just a bit longer than yours still. But other than that, I'd use the x minus 1 version at first. And I basically came up with the same thing. It's written differently, of course, which would be minus x to the negative 2. But yes, when I was working out via first principles, I just basically took longer than I needed to because I multiplied out everything, especially the xh, x plus h at the bottom.
What on though? Did you use first principles in doing the question, Donald?
Right. Okay. Yeah. So what I was just saying is that at the last step, where it's like xh, x plus h at the bottom, basically went and multiplied out everything, then figured out that I should not have done that, and got that right answer.
All right.
So where before we do the lowest count, let's see that I was just stuck before there. So I had everything written down. I would just never know how to get it from there.
Fair enough. All right. Coming back to you, Donald, and the rest of the class. Whenever you're doing a differentiation question with a numerator and a denominator, never, ever, ever, ever try to simplify the denominator.
Got it.
Never, ever, ever, ever try to do that. Only try to normalize the numerator, leave the denominator as is. And when I move into the quotient rule, you will see why. Never, ever, 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 never, ever try to do anything to the denominator. It will throw you off and effort in futility. It won't add any more points to what it is that you're getting. Chances are it will take off points because we're going to make some mistakes. Question now. The rest of you, how you stay? Dan, I get very worried when you're very quiet. Have I lost you, Dan?
No, man, I understand, sir.
Okay. Is there anybody in the class that I've lost? It's important for you to just speak the truth to me now, than waiting until a mid-semester or waiting until a final exam. I know the truth.
So you don't mind run through the explanation again?
I have no problem. That's why I asked the question. I have no problem. All right, so let's go. So you're given a question. The limit as h tends to 0 of 1 over x. And they say to you, differentiate using first principles. Differentiate using first principles. If you use any other method other than first principles, 0 mark. It don't matter if you answer right 0 mark. So Joe says, sir, I did a question in my head before, and I knew what the answer was supposed to be. Very good. Because when I do the question like that too, I do the question in my head too. But if they said to me, use first principles, and I use anything other than first principles, 0. So I have to follow the instructions based on what they're asking. And sometimes you go into the exam and they will say to you, by using first principles, differentiate the following. So if you decide to say, sure, you can use the product rule or the chain rule or the quotient rule or the power rule and get the correct answer, you're wrong. 0 mark. Because you would not have followed their instructions. So I say this to say to you, you don't have a choice but to learn this area of differentiation. So let's go. Remember, the formula is always the limit as h tends to 0 of f of x plus h minus f of x all over h. Yes, I agree and I understand that, sir, is another formula for us to remember. I know. Empathize with you, but it's another formula that you must know. All right? So this is it. Every time I'm doing first principles and I come across a x, I have to write a plus h beside it. That incremental change, I must write a plus h beside it. And then when I've done all of that, I now need to subtract my f of x in its entirety from it, which is here, minus my f of x. Interesting to note, if there's only one term like this one here, 1 over x is just one term, there's no need for me to use my parentheses. If, for example, I have multiple terms, like this one here, I have 3 terms, 2x squared plus 7x minus 5, they must be enclosed in parentheses. You know why? Of this negative sign. That negative sign is going to be distributed through right across every term in the parentheses. So if you don't put the parentheses, chances are you're only tempted to distribute the negative sign with just the first term, and the other 2 terms will not be able to be cancelled out. And you will add them and the question being wrong. All right, so just remember. All right, I digress right there, just to let you know. And then I recognize that I'm going to have a numerator that has a fractional form. You know what? Let us just work the numerator first now. And then this division by h here, I'm just going to convert it to 1 over h. That division by h, I'm converting to 1 over h. I'm converting it to 1 over h. So let us work out our numerator. Yes, hon.
So you're working the same percent from before, right?
Yeah.
Because I not see it moving anything across the screen. That's right.
Anybody see my screen? Because I'm circling stuff. You not see my screen? Anybody see my screen?
Just came up.
I'm
just
huh?
Sorry, just go.
It just came up. Okay, all right, cool. Yeah, man, but I was using it. All right. So I am working out my numerator, but my numerator is fractional. So I'm going to go ahead and find the LCM for the numerator. Sir, do I always do this when I get a fractional form? Yes. 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 And another yes. So my LCM is going to be the product of 2. Just take it from me. LCM is going to be the product of 2. It's going to be this one times this one. So you're just going to multiply it out? No. I was going to write it as a product of 2 things. I'm not going to distribute the x over the x plus h, like what Donald said that he was doing. No. I was going to write the product of 2. Then I said to myself, what is common between x plus h and x times x plus h? Is going to be x. Because how many times can x plus h go into x times x plus h? It will be x times. And then x times the one in the numerator is just going to be x. So this is why I get the x right here. All of this is the same thing as adding 1/2 plus a quarter, not to give you 3/4. The only difference now is that we're not using just concrete values, we're using some abstract values, x and them things here. So it's the same thing that we have been doing. Same thing we have been doing. Same thing we have been doing. All right. Then I'm going to have my numerator as in x minus x times x plus h. Remember, we will only simplify the numerator. We will only simplify the numerator. We will not simplify the denominator. We will only simplify the numerator. So what we're going to do, we're going to distribute that negative sign into the x plus h. So -1 times x is negative x, and -1 times positive h is going to be a negative h. Remember, when you subtract your f of x, all of your f of x must be cancelled out from your f of x plus h. All your f of x must be cancelled out from your f of x plus h. Very, very, very important. All right. Okay, let's go. So now, when my x is cancelled right here, I'm going to be left with this minus h. So yes, Joe, I know I'm doubling up the steps, but I don't want to perform multiple steps in one line, and then you're not able to follow. So I'll go to the long route of writing out step by step by step. So what is going to happen is that I'm going to end up with a negative h in the numerator, and I'm still keeping my x times x plus h. Watch me. You see, from when I catch my x times x plus h right here, so boom. I keep it right here, so boom. It there right here, so again, boom. Right here, so again. Right here, so again, right up to the end. I am not going to do anything to it. I'm going to keep it. Please, I beg you, the questions on, we call it first principles, if you do get them, it's anywhere between 5, 6, 7, 8 marks. And sometimes they give you 2 of them in one question, part A and part B, for 5 marks each. So you're talking about a 10-mark question. Follow the rules. Follow the rules. We can't go wrong. Follow the rules. I guarantee you, we can't go wrong. Follow the rules. You're good to go. And then, what I'm going to have now is that as h tends to 0, no, remember I can't do h tends to 0 yet until I do my division, my cancellation. I have to first cancel out my h. And let me tell you, let me ask a question to see if you guys are following. Why is it that I must first cancel my h before I move into substituting h equals 0?
Sir, because you're going to get undefined. Sir, because, sir?
That is correct because
Why is it that it is important for me to first cancel before I apply as h tends to 0?
Sir,
Huh?
before,
that
sir,
is
when I
yes.
apply h tends to 0, you're going to get 0 over whatever.
That's
So you're
right.
going to get 0 over x squared.
Sorry, you're in and out, Joe. I hear Donald say that's right. Tell me again,
Sir?
Joe.
So I was going to say you're going to get 0 over x squared, which is undefined.
0 over x squared is undefined?
Sir, math error.
Your line of argument is correct, but your function is incorrect. Talk to me now.
Sir, what do you mean?
Look at this h right here, so this h. If I put this h equals 0, what is going to happen?
Sir, 1 over 0.
Very good. And don't tell me that you said that because you never did. You're now saying
Sir,
that.
the other one, the one below it is what I was looking at. That's why.
Is this h you're talking about, man? So now tell me, you're going to have 1 over 0 and use a statement that you made to me earlier a while ago. And 1 over 0 what?
0 over x squared.
No, man.
Sir, 0 over x.
Because it had not been
1
cancelled
over
out of
1 over
0
and 1 over 0 is
infinite.
1.
Is infinitely or is infinite or undefined or math error. Didn't you just say that a while ago, Joe?
Yes.
I'm gonna take away your Sunday dinner. I mean your Saturday dinner.
Sir, you can't keep it.
Sure. Yeah, man. So I have to do my cancellation first because if I don't, it means that I'm going to end up with something that is undefined when it is really not undefined. So I have to first remove what is going to cause a function to be undefined. You know, like when you're sick and you tell the doctor, oh, doctor, I have a fever. But I'm feeling pain anyway. So whenever you have a fever, you don't take it lightly because the fever is saying that there's some infection somewhere. So it is known for the doctor to go and find out where else is it hurting you. And then you say to the doctor, and then the doctor knows try to diagnose it thereafter. So you have some things that give you indicators to what is really happening to you. This is a mathematical indicator. I have to first get rid of my h before I can decide what is next. If not, I know something is all right, something all right. We can say it's not safe. We have to then find out what makes it unsafe. And it's at h. So when we do the cancellation, then we can proudly go and say when h equals 0, what the function tends to. And then this is what we're going to do right here. So I would have done my cancellation at this stage. See it right here, so? My cancellation took place right here, so I'm just rewriting the stuff. When I cancel h from h, I'm going to have 1 left. So this is why I have this negative 1 up here. And then this h cancels out, so I'm just going to be left with x times x plus h. See here? X times x plus h. So as h tends to 0, all of this here is when this will go 0. So I'm just going to have x times x. See here? 1 over x times x. And x times x is x squared. See here? 1 over x, negative 1 over x squared. Now, hear me out. When I'm finding the limit as h tends to 0 of negative 1 over x squared, this negative 1 over x squared becomes a constant. Tell me why negative 1 over x squared becomes a constant. Let me see if you're thinking. It becomes a constant because negative 1 over x squared is a constant. It is a constant because?
So because there's no parameters to change it.
Yeah, but when you use them big words, I don't know what parameter mean. Tell me,
Basically,
because
nothing to put into the variable x. X is just whatever. X is just x.
and the parameter that he's speaking about is that there's no more h to substitute into the function. You follow what I'm saying? So
Got
that's
it.
why, right. So that's why it is what it is. -1 over x squared. So the parameter is removed. So since the parameter has been removed, it now becomes a constant. Now that it becomes a constant, the limit of a constant is the constant itself. So this is why this -1 over x squared is again written as my answer as -1 over x squared. And that's why it is written as -1 over x squared. All right? Terrible. Any clearer?
Yes, sir. Clear enough.
Man, it's very important to know. That's why I take my time to go through
Yeah,
the
man,
stuff
that's why
first.
I asked, because I want to
Yeah,
go,
man.
you go through step by step to ensure
Yes,
I
man.
understand.
Yeah, man.
Thanks.
No problem. But guess what? When me taste curry lobster one time, don't ask me how it tastes, you know. You have to go buy it for me one more time so I can taste it again. Because the first time I would have been excited. So the excitement in doing this rational function is now in the air. So let us go ahead and do one more on your own now. So that Tara can tell me that, sir, I get it. I understand it 100%. Right, Tara Boo?
Yes, sir.
All right. So let me just generate another question and give you some time to work it. Let's see. The seventh slide. And I'm going to ask it for the limit. The limit as h tends to 0 of 2x over, you know what? I'm just going to give it x plus 1. 2x over x plus 1. I know he more than 5 minutes, you know. 5 minutes. On the mark, get set, go. All right, students, I'm going to step away for about 10 minutes. Calculus one. I'm going to step away for about 10 minutes, but I mean, I'm going to have my device with me nonetheless. I can answer your question, but I won't be able to write on screen because I am stepping away for a few. So continue working for me, please. And if you have any questions, you can definitely talk to me about those. Number 16 is 813, 130. Are you guys okay? Hello, are you guys okay?
I'm here, sir. I don't want to see. I don't know if I get it right, so. Hearing me, sir?
Oh, hold on 1 minute, please. Yeah, man, I'm coming. Give me 1 minute, guys. All right, guys. All right, guys. Were you able to do that question?
So I try attempt it, but I don't know if it's correct. So,
What you got for the answer?
well, where I stop I have 1/x² plus x minus x. That's where I stopped. I didn't. So I was wondering where I stopped. Or I don't know if I did it correct.
What say the rest of you? What the rest of you have? Anybody has completed the question in its entirety?
I'm not hearing anybody else. I don't know if they're in.
No, man,
Yes,
they're
sir.
there,
I
man.
completed the question. I got 2/x.
You got 2/x for the question?
Right.
No, the answer is supposed to be, the denominator is supposed to be x plus 1 all squared. The answer for the denominator is supposed to be x plus 1 all squared. So you must have an x plus 1 all squared in your answer for the denominator, or else it's not correct. Anybody has an x plus 1 all squared in the denominator? Anybody has an x plus 1 all squared in the denominator?
Sorry, repeat for me, please.
Anybody has an x plus 1 all squared in the denominator?
No.
No, well, it's not correct. Because remember, you're always going to, based on the two questions that we did, you recognize that we end up with, well, the one question that we did with the quotient, quotient, but the one with the denominator, the function, you're going to end up with some square in the denominator. You always have a square term in the denominator. So what I'm going to do, I am going to be completing the question for you and send it off just in a few, and then I'm going to give you some to try on your own to see how best we can work it out. But you will always end up with a square term in the denominator. Just remember that. You'll always end up with a square term in the denominator. If you don't, it means that something is off. Fair enough?
Okay, sir.
Okay,
All
sir.
right. All right, cool.
Sir,
So,
there
yeah, go
is no
ahead.
date set for the midterm.
After the midterm, the Saturday following,
Okay.
not Holy Saturday, but the other Saturday, we'll consider doing it.
Okay.
All right, cool.
Sir.
Yes, sir.
So this is first principles where the quotient rule we're talking about.
Yes, but we don't get into the quotient rule yet, it's the first principle that we're looking at. So I'm going to send you some stuff on the first principles, because what I want to do is to move into the quotient rule, move into the chain rule, the product rule,
Okay,
and the
sir.
power rule, right? So it's just, yeah. All right? All right, all the best. Take care.
Take care, sir.
Mhm.